So as we continue to work on solving quadratic functions, we do need to talk a little bit about simplifying square roots. Most of the square roots we have seen up to this point have been perfect squares, like this one right here. So the square root of 16 is, well, 16 is considered a perfect square because it's made up of 4 times 4. And so if I'm being asked to simplify the square root of 16, I will get a whole number answer. I can have 4 or I can use -4. And a lot of times when we're asked to solve this, we'll actually write this as plus or minus whatever number it is we're dealing with. So in this case, it's 4. But I still can actually simplify when I don't have a perfect square. For example, the square root of 20. When we have a non-perfect square like the square root of 20, what we can actually do is break it into its different factors. So, for example, 20 can be broken into 4 times 5. And one of the properties of square roots is that I can take the square root of 20, or I could take the square root of 4 and multiply it by the square root of 5, and I'll get the same number. But what this also means is that I can actually break my square root of 20 into those 2 separate pieces and take the square root separately, which, because the square root of 4 is a whole number, I can simplify that, and I can leave the square root of 5 alone. And so my answer to what is the square root of 20 is plus or minus 2 square root 5. Take a minute, pause the video, and try this with the square root of 50. Think about what factors could you break 50 into, and what factors of 50 are perfect squares. So thinking about my factors of 50, I can break 50 into 25 times 2. The square root of 25 is going to simplify, the square root of 2 is not. And so my answer here is going to be plus or minus 5 square root 2. We can use square roots to solve simple quadratic functions like the ones shown here by just taking the square root of both sides. The big key to this is remembering that we are going to want to simplify whatever number we're taking the square root of, and we're going to have to say it's both the plus and minus version of that particular number. So for example, if I have this x squared equals 16, I can take the square root of both sides, and x is going to be equal to plus or minus 4. Same thing here with the square root of, or rather with x squared equals 60. If I take the square root of both sides, I have to think about simplifying 60 by breaking it into 2 or more pieces to see what I can, what parts of it I can simplify and what parts I can't. Now 60 breaks into the square root of 4, and the square root of 15. The 4 is going to simplify, the 15 is not. And so my answer here is going to be x is equal to plus or minus 2 square root 15. Take a minute, pause the video, and see if you can do these 2 problems here. X squared equals 100 and x squared equals 36. So these are both going to work out to being perfect squares. I'm going to end up with x is equal to plus or minus 10. And over here, x is equal to plus or minus 6. What about in situations like this? So in this particular equation, we have x squared is equal to -9. And we run into a bit of a problem here. If I go to try and take the square root of both sides, I have an issue because I'm not allowed to take the square root of a negative number. The square root of a negative number doesn't exist. There is nothing that I can do times itself that's going to give me a negative number. There are ways that we can simplify this, but this does lead us into a conversation about complex numbers. So to simplify, what we're going to do is we're going to break -9 into 2 pieces. We're going to break it into the part that we are allowed to simplify, which is 9, and the part that we can't simplify, which is -1. So we have the square root of 9 and the square root of negative 1. Now, the square root of 9, we can simplify. This turns into 3. But the square root of negative 1 is a problem. This is not a real number. In fact, we refer to this as I, which is an imaginary number. Now, the great part about I is it always has the exact same value. I always represents the square root of negative 1. But what it does let us do is every time we go to figure out the square root of a negative number, we can simplify the part that's actually negative by turning it into I. What this does is it allows us to basically create a real and a non-real part to my solution. So my solution for this particular problem is going to be plus or minus 3i. What this does mean is if I go to graph this particular parabola, this is never going to cross the x-axis. I don't have any real solutions, but I do have two imaginary solutions, and they are 3i and negative 3i. So this is going to work for all of our perfect and non-perfect squares. So if I have something like the square root of negative 16, I can break this into the square root of 16 times the square root of negative 1. The square root of 16, we know, simplifies to 4, so I'm going to have plus or minus 4. And then because I have that negative 1, it's going to turn into I. If I have a non-perfect square, the same thing happens. I'm going to break this into the square root of 15 times the square root of negative 1. My square root of negative 1 is going to be represented with I, so I have plus or minus I, and then the square root of 15 does not simplify. So that I portion is going to come first, and then the square root of 15. Same thing for the square root of negative 200. I'm going to break this actually into 3 pieces. I'm going to break this into the square root of 2, which does not simplify, the square root of 100, which does, and the square root of negative 1. And then I'll simplify each piece individually. The square root of 100 is 10, so I have plus or minus 10. The square root of negative 1 is I, times the square root of 2. Take a moment, try the square root of negative 32. Pause the video, give it a try. So this is going to break into 3 pieces as well. I'll have the square root of 2, the square root of 16, and the square root of negative 1, which is going to turn into plus or minus 4i square root 2. Now, we can do operations with complex numbers as long as we remember that our complex numbers are always going to break themselves into sort of 2 bits and pieces. The first is this first little bit here that I'm representing with the letter A. This is going to represent our real part of our number. And then we will have this other part that is our imaginary part. And the deal is that we can add together or subtract together our real pieces, and we will also add and subtract together our imaginary pieces, but we will do it separately. I personally like to think about I like it's a variable. So if I have something like this, where I have, let's say, 6 plus 2i minus 7 minus 3i, my 6 and minus 7 will combine to give me negative 1, and then my 2 imaginary pieces, 2i and negative 3i, will also combine and give me negative 1i, or just negative I. I can also multiply complex numbers, and I'm going to multiply them actually the exact same way that I would multiply 2 binomials. In fact, I can even set up the box method to help me to do that, or I can do this through FOIL. But something interesting is actually going to happen when I do this. So everything kind of starts out the same, right? So 4 times 2 is 8, and 4 times 3i is 12i, and negative 2i goes here. But this is where things get a little bit interesting, because when I do 3i times negative I end up with negative 3i squared, which, if you remember, I is equal to the square root of negative 1, which means that I squared is equal to the square root of negative 1 squared, which is just negative 1. And so this here is actually negative 3 times negative 1, which is just positive 3. And so when I go to combine like terms here, these two are going to combine like they usually do, but these two terms here are also going to combine. So 8 plus 3 gives me 11, and 12i minus 2i gives me positive 10i, which is going to be my final answer here. Here are 2 examples for you to try. Pause the video, try them, and then unpause the video to see the worked out solutions. So here I've gone through to highlight the terms that I'm going to be able to combine, and the first thing I'm going to do is combine my real numbers. Then I'll go through and combine all of my imaginary numbers. These 2 things I can't combine, so my final answer here is going to be 6 minus 2i. For my multiplication problem, I am first actually going to set up the box method, though you are absolutely welcome to do this using the FOIL method as well. Then I'm going to go through and fill in all of my cross products. So I'm going to multiply each thing across from each other to fill in the individual boxes. Finally, I'm going to swap out my I squared with negative 1, because again, I is the square root of negative 1, so I squared is just negative 1. And then I'm going to combine like terms to simplify. And there's my final answer.